Hello and welcome to Module 15 in our C language series. In today's session, we're going to be focusing on miscellaneous functions. This is a brief introduction. Most of the functions we're going to discuss today require the use of the header file std.lib.h. We're going to discuss some new types like div-t and eldiff-t. We've already discussed size t type in terms of the string.h header file. But it's important to mention to you here that the definition of size t in the header file string.h is directly coming from the size t definition in std.lib.h. We have macros that we're going to discuss. Now we already know about null, but we're going to discuss rand max, which is to do with random numbers, exit failure, as well as exit success. Now coming to the first function, the abort function, and you can see from the prototype, this function returns no values and takes no arguments. The function causes immediate abnormal termination of a program, keywords there being abnormal termination. And so this function is called when there are major internal inconsistencies. For example, a heap overflow, right? But having said that, we'll just use this function in our code to see how it works. What about open streams, buffered output, and files? If this function is called when there are major internal inconsistencies, well, open streams may not be closed, buffered output may not be flushed, and files may remain incomplete. Right? For example, if you're writing to those files. What about return value? As you can see from the prototype, there's no return value. But what we can do is we can have a handler, which is nothing but a set of instructions, which in turn is nothing but a function that will execute when abort is called. Right? So that will be triggered once the abort function is called. This function actually terminates the program by raising a signal called sig_abrt, and all signals are defined in the header file signal.h, which means when you're using the abort function, we need to include in our program the header file signal.h. The program terminates with exit code 3 when we use the abort function. Right? Now coming to atexit, and you can see from the prototype, this function returns an integer and takes as argument a pointer to a function. This function registers the function pointed to by func, right, which is the argument, as the function to be called upon normal termination of the program. Note that the argument, that is func, returns no value and takes no arguments. So atexit returns 0 if func, that is the argument, is successfully registered as a termination function, otherwise returns non-zero. So when is atexit used? So this is mostly used when you have, for example, a shared library of functions, right? Meaning you can use any of those functions from that library, and you want to include some cleanup functions that will execute when that shared library is unloaded from the application. You will not have the developer having to call those cleanup functions explicitly, right, when you're writing a shared library of functions, but you'd rather have those cleanup functions execute invisible to the developer, and that's where you will use atexit. But having said that, we will just use it in our code to see how it runs, right, and what it does. So now we write a simple program that will allocate memory for a structure as follows: student name maximum 20 characters, age, email ID, grade, with grades running from 1 to 13. If memory cannot be allocated, the program should be terminated. We can use abort there. The program should contain a function that runs on normal termination, printing an appropriate message. So now let's go to code blocks and we start a new file. So hashtag include stdio.h and hashtag include stdlib.h and hashtag include signal.h, because we're going to be using sigabort or sigabrt. Then we have our structure, so struct student, and within that we'll have char name of 20 bytes, and then short int age. Then we'll have char email of 20 bytes. Then we'll have short int grade. Now we'll define two functions. One will serve as a trigger. We'll call that trigger. This will be the handler that will run when abort executes or abort is called. And we'll have another function, let's call that goodbye, which will run or will execute when atexit is called. Right? Now we'll have a struct student, and we'll have a pointer to that structure, star ptr int main. And here we see signal. Now signal is a function that takes two arguments. One is the signal itself and the action to be taken when that signal is raised. Okay, so it provides an interface essentially for doing something when a signal is raised. ptr equal to struct student star, right? Mark the syntax for when we are allocating memory using malloc for a structure. So malloc size of struct student. Okay. Then we check if not ptr, that is if ptr is a null, then printf and abort. Otherwise, printf enter name and then scanf %s comma pointer, that's ptr, the arrow operator and name. Then printf age and scanf %d comma ampersand ptr arrow age. Note the syntax again. Then we have email and scanf %s comma ptr arrow email. And lastly we have grade and scanf %d comma ampersand ptr arrow grade. Right? Then we print out the details. So printf \n printing details \n, and now we'll just print out all the details. So printf name %s \n comma ptr arrow name, and then printf age %d \n comma ptr age, so that's with the arrow operator of course. And then printf email %s \n comma ptr arrow email, And finally, printf grade %d \n, comma, ptr grade with the arrow operator, right? Now we'll just free ptr and we'll call atexit with the function goodbye as argument. Now that main is defined, we'll just define our handler, so void trigger, and we have the argument in air, and within the function, this is really something trivial, but just to see how this works, we'll have aborting. Of course, this may not happen because memory will be successfully allocated, hopefully, so we will not have this. In case we don't, then we'll see a demonstration of how abort works. Goodbye, and no arguments there. Within this function, just put s and signing out. Again, something really trivial, as I said. Atexit is used mainly to have cleanup processes in place for when we write shared libraries. Right, so now let's run this. Put in some name, age, email, and grade. And there we have the details. And of course, abort did not execute, right? Because memory was successfully allocated. So let's now go and just see a demonstration of that. And you don't need to really write this code. And here we'll have hashtag include stdio.h and then hashtag include stdlib.h and hashtag include signal.h and hashtag include ctype.h because we're going to use toUpper, the function that is. And now we'll just have void trigger sending in the integer type argument int main, and within this function we're just going to say our answer equal to just n and printf, and then we get the input answer equal to get char, and then we just call signal passing in sig abrt comma trigger, right? And we check now if toUpper of answer equal to y for yes, then abort. And now we'll have our handler outside main, so void trigger int air, and within this we just say printf. If I run this now, there seems to be some semicolon there. So let's say yes. Now you see sigabort raised, and let's see the exit code, and you see process return 3, right? Okay, so that's how abort works. I hope that's clear. Moving on. A to I, Ascii to integer. And from the prototype, this function returns an integer taking as argument a constant character string. Converts the string pointed to by str into an integer value. The string must contain valid integers, of course. If not, the return value is undefined or 0. So now write some code. You are given input of 10 employee salaries in string format. Convert them to integer and deduct standard tax of 5% and print out salary after deduction. So let's now go to code blocks and we start a new file. And here hashtag include stdio.h, and then hashtag include stdlib.h. Int main, and we'll have here char star str1. So this is a double dimension array, right? Equal to, you're testing the program just with 5 salaries. Okay. Int I equal to 0, and we'll have net salary as well. And then for, now we don't need initialization because we've already initialized I there, right? I less than 5 and I plus plus. And within this loop, we say net sal equal to a to I of str1 of I, right, minus a to I of str1 of I into 0.05, right? This should be outside. Okay. And then we print %d \n, comma, net salary. And that's all. And now we can use exit with exit success. Exit success has the value 0. Okay. And now let's run this. This should be sal. Okay, we've got all zeros. Why is that? We've got net sal equal to a to I of str1 of I. So there has to be actually a bracket here, right? Minus a to I. Let's put this in brackets as well, into 0.05. Right, let's run it now. And there you have it. Right, so I hope that's clear. What about exit failure? So if we just do a printf here, we will be able to see the value on screen. So printf, comma, exit failure. So now we run this. And you see exit failure has value 1. Right? And we have been using exit with status 1 whenever we've had to exit a program for failure. Right? So moving on. A to F, and this is Ascii to float. From the prototype, you can see this function returns a double and takes as argument a string. Converts a string pointed to by str into a double value. The string must contain valid floating point numbers. If not, the return value of A to F is undefined. So you are given a list of prices of products in character format, convert them to double and print out net price after adding a tax of 20%. So let's go back to code blocks and we start a new file. So what I'm going to do here is we're just going to copy this code because it's essentially going to be very similar. Right, so we have now str1 and we'll put in some prices here. And we're going to use pointers here, right? So what we'll do after this last value, we'll put in a null. Okay. And we'll have here char star ptr. This is double indirection now, equal to str1. Right? Remember, this is a double dimensional array, so we're using double indirection pointer. Now here we'll have one more variable, and we'll have float net price. Right? And instead of this loop, we say here while star ptr not equal to null. And within this, within the while loop, that is, we'll calculate net price. So net price equal to atof of star ptr plus atof of star ptr into 0.2, right, for 20%. Right, and then we can just print out the value. So printf percentage 2.2f backslash n comma net price. And then of course ptr plus plus to go to the next value. Right, let's run this now. And you can see we have those values nicely printed out. Now what you can do is you can use pointers in the previous program. I'll leave that up to you. Right, moving on. I to A, that's integer to Ascii. And from the prototype, you can see this function returns a character pointer and takes as argument int num, and then a string, and int radix. So radix will be the base, and that can be binary, it could be decimal, right up to hexadecimal, which is 16. Returns a pointer to str, converts the integer num into its string equivalent, places the result in the string pointed to by str, right? The base of the output string is determined by radix, and as I said, it can run from 2 to 16. So for this one, what we do is, you don't need to write this code, because this I'm just going to show you a demonstration of how it works. So hashtag include stdio.h and hashtag include stdlib.h. Int mean, and we'll have here char p of 20, let's see, and I to A, let's pass in the value 4800. We want it put into the string p, and its base is going to be hexadecimal, so 16. And then just printf p, and that's all. If we run this now, that's the hexadecimal of 4800, right? Remember, C is 12, right? Because A is 10 in, or 10 is A, I should say, in hexadecimal, 11 is B, and 12 is C. Runs from 0 to 15. Moving on to div now. As you can see from the prototype, this function returns a div t type. Right? And we'll see what that is shortly. Takes as argument int numerator, and int denominator returns the quotient and remainder of the operation numerator divided by denominator. Return value is in the form of a structure of type div t. The structure has two fields at least, int quote and int rem. Now what we're going to do is we're just going to see a demonstration of how this div function works. So we'll do that in this file itself. Just comment out this code. So here what we'll do is now we'll just have a div t type. So div t, and that will be, let's say, n And then we say n equal to div and pass in some values. So let's say 10, comma 3, right? And now printf, comma, n dot quote, remember it's a structure, and n dot rem. So if we run this now, you see the quotient and remainder 3 and 1, right? Okay, so that's about the div t type. Similarly, you have Eldiff, and it's called Eldiff because it takes long arguments. So you can see from the prototype, this function returns an Eldiff t type, right? And takes as argument long numerator and long denominator, returns a quotient and remainder of the operation numerator divided by denominator. The structure type Eldiff t is defined in std_lib.h and has at least 2 fields, long quote and long rem. I'm not going to write any code for this, very similar to the previous function we discussed. Coming now to rand, the prototype you can see returns an integer, right, taking no arguments, generates a sequence of pseudo-random numbers. Each time it is called, an integer between 0 and rand max is returned. What the value of rand max is implementation defined. Now write code to generate random numbers. So now let's go to code blocks and we'll start a new file. So hashtag include stdio.h and hashtag include stdlib.h, int main, and here we just have int counter equal to 0. We have r equal to 0 as well. We can say for counter less than 10, counter plus plus, and within this loop we'll have r equal to rand, and that's all. Right? Printf %d \n, comma r. Very simple program, just generating 10 random numbers, right? So now if we run this, there you have them. Now these are numbers generated between 0 and rand max. But what is rand max? Well, you can check by printing it out. So printf %d \n, comma, rand max. If you run this, you see rand max is 32,767 as far as our implementation or my implementation goes, right? So that's about the rand function. If you want, for example, the random numbers to be generated only until 100, then what you can do is just put in a percentage there, 100, and now you will see the random numbers generated are between 0 and 100, right? Similarly, you can put in 1000, so that will be 0 and 999 essentially, right? So that's what you'll get. But notice one thing, the first number generated is 41. If I run this again, I get the same numbers. What if I wanted different numbers every time I ran this? In that case, we will have to use srand. And this function, you can see from the prototype, returns nothing, right? But takes an unsigned seed. Okay, so we are kind of setting the starting point for that sequence to be generated. Generally used to allow multiple program runs to use different sequences of pseudo-random numbers by specifying different starting points. right? So modify the code written earlier so as to set the starting point for producing the series of pseudo-random integers. So let's go back to the code and we'll just change that code. We'll have to include here now time.h, right? And here after this line, we'll just say srand time passing in 0 as the argument. That's all you need to do. Okay. So now if we run this, oh, there's a spelling mistake there. Srand. Right, so now we run this. So you get these numbers now. If you run it again, you see it starts with a different number. If you run it a third time, you'll start with a different number again. Right, so that's about srand. Hope everything's clear. This ends our session. In the next session, we'll talk about more miscellaneous functions. Till then, take care, stay safe. Bye.